Hello, everybody. Here we are, 3.5, dividing whole numbers with fractions. We're going to use a decent number of models and number lines today. And I don't have a lot of notes, just kind of instruction. I mean, one thing I'm just going to suggest you estimate to check your answers. That's a piece of advice I'm going to give you for this section because there's a kind of slightly counterintuitive thing going on when we divide by fractions. 4 divided by 2 equals 2. We're dividing it, it's getting smaller. That makes sense. But when we divide by a fraction, when we divide by something less than 1, our number is actually going to get bigger. So as long as our fraction is less than 1, our number is going to get bigger. So that's a kind of counterintuitive thing that would be, I think, useful in this lesson to estimate and check. And hopefully it'll make a little bit more sense as we go on, and you'll see, why this is so. Okay, so let's go on to our first question. Use a number line to find each quotient. Remember, the quotient is you can write this down, answer to a division question. Call this quotient. So we have 4. Here's our number line. This is 1, 2, 3, 4. And we're dividing it into thirds. So you'll notice we have these little lines here. We've divided this into thirds. Okay, so this 1 is now in 3 parts. There's 1 part, 2 parts, 3 parts. It's divided into thirds. This is another parts. So that's what it means by we're dividing. We're showing this on our number line. And now to get our answer, we just need to count up all of the 1/3 that go into 4. So there's 1/3, 2, 3. So I go 1, 2, 3. This is our 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th. 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 divided by 1/3 is 12. I think sometimes it can be helpful also if you draw it in squares like this, might be more helpful than a number line. So if you have 4 of something, I remember a teacher friend of mine always talked about chocolate bars. She always says chocolate bars for this. So you have 4 chocolate bars. You've divided each of them into thirds. And now how many sections of chocolate bar do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts of chocolate bar. Okay, let's do the next one. Now we have 4 again on our number line right here. And now we're dividing it into 2/3. So we still have it split into threes because we're still looking at thirds. But now we want to know how many times can you pull out 2/3 out of this. So if I make a jump, there's a jump of 2/3. This is 1/3, and this is 1/3. So I've made a jump of 2/3 now. Now I'm going to make another jump of 2/3, and another jump, and another jump, and another jump, and one last final jump to 4. Now we can count our jumps. 1, 2, 3, 4, 5, 6. So we made 6 jumps, and 2/3 can be pulled out of 4 6 times. We had our chocolate bars, and you were splitting it into 2/3 pieces. There would be a 2/3. There would be another 2/3. There's a 2/3. There's a 2/3. There's one, and there's one. So ultimately, 1, 2, 3, 4, 5, 6 2/3. Now let's look at the other way, dividing a fraction by a whole number. So here's our number line. We have it at 1 because remember we're looking at a fraction, usually less than 1. And this is split. Actually, these little lines would split it into tens, and we have 4/5. So this would be this line right here is 1/5. This would be 2/5. This would be 3/5, and this is 4/5. 1/1 would be 5/5. And now we're going to split this into two. So how do we split this into two? We think about going from one to one jump and then one to another jump. So we split this into two parts. And now you can see what is one section is 2/5. That equals 2/5. Okay, so each of these represents 2/5. That's 4/5 divided by 2. Okay, let's do our next one. Again, we would have, there's one, that's okay, I can do green. 1/5, this would be 2/5. This would be 3/5. This is 4/5 right there. There's our 4/5. And then again, this would be 5/5. That's 1. And now we're splitting it into 4. So we're looking to make 4 equal jumps. There's 1, 2, 3, 4 equal jumps. And how much is each of our jumps? Each of our jumps was 1/5. So the answer is 1/5. For those of you folks that don't love diagrams, we're going to do a little bit more, and then we'll get into the keep, change, flip method, and you might like that a little bit better. But I just want to show you some diagrams and what this actually is happening here, so you might understand it a little better. Next, we're going to use fraction circles to illustrate the answer. You might like this a little bit better than the number line. I do, I think, personally. So we're going to draw 2 circles. That's our 2. And now we're going to split them, or we're going to divide them into 3s. So something like this, looks like a peace sign. We divided it into 1/3. And now to get our answer, we just need to count up our sections. There's 1, 2, 3, 4, 5, 6. And 6 is our answer. 2 divided into thirds gives us 6. Let's do another one. Let's draw our 3, 2, 3. We're going to divide it into quarters, okay? So you always go by the denominator. So I'm going to divide it into quarters like this. But we're not looking for 1/4. We're looking for 3/4. So we have to count how many times can we pull out 3/4 out of this. So here's a 3/4. That's another 3/4. Here's another 3/4. And finally, there's our last 3/4. So how many 3/4 did we get? The red is 1, the green is 2, the purple is 3, and this light blue is 4. So the answer is 4. We can get 4 3/4 out of 3. And let's do the next one, and you'll start to see why, sometimes diagrams aren't great. You start to draw too many circles, it can get a bit tedious. So we got 3. We're going to split it into 3s. So our peace signs again. But this time, like last time, we're looking for 2/3. We're not looking for 1/3. We want to know how many times can we pull out 2/3 out of this 4. So there's 2/3 once. There's another 2/3. There's another 2/3. There's another 2/3. There's another 2/3. And let's do this green. There's the last 2/3. So let's count them up. The red is 1. The orange is 2. The green is 3. The purple is 4. The black is 5. And this neon green is 6. So the answer is 6. You can get 2/3 out of 4 6 times. And our last one, this is going to be, slightly annoying to draw. Actually, I'm going to do it as squares. I like that a little better. I'm going to draw 5 squares. And I want to split each of them into 5ths. 2, 3, 4, 1, 2. Okay. And now we want to know how many times can you get 1/5 out of this? Well, it's going to be a lot of times. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 times you can pull out 1/5 out of 5. Okay, so there's all of our diagram stuff. Maybe I'll give you a moment to write it all down. And now let's do the kind of just straight math one. This method we call keep, or I call, or lots of folks call keep, change, flip. So if we are dividing fractions, and we are going to turn this into a fraction, even though it's a whole number, we're going to turn it into a fraction. We're going to keep our first fraction, 3 out of 4. We're going to change the symbol. Okay, it's division, but it's going to change to multiplication. And we're going to flip or tape the reciprocal of our last one. So the 1's going to go on the top now, and the 3 is going to go on the bottom. So now we got 1/3. And now we're just going to multiply like we're used to. First, we can cross reduce right here and right here. 3 goes into 3 once, and 3 goes into 3 once. And let's multiply our new tops. We got 1 times 1 is 1, and 4 times 1 is 4. Okay, there you go. Now let's do it again. Keep, change, flip. We're going to keep the 6/5. We're going to change to our division to multiplication. And we're going to flip or take the reciprocal of our last one. So 3/1 becomes 1/3. Now we're going to cross reduce as usual. I look here, I can see 6 and 3 have a common factor. I know that 3 can go into each of these. 3 can go into 3 once, and 3 can go into 6 twice. Now let's multiply our tops. 2 times 1 is 2, and 5 times 1 is 5. And there you go. Let's do our next one. We're going to keep the first one, 5/8. We're going to change the symbol to multiplication, and our 4/1 is going to become a 1/4. In this case, no common denominators. Nothing goes into 5 that also goes into 4, and nor 8 and 1. So let's multiply the tops. 5 times 1 is 5 over 8 times 4 is 32. And let's do our last one. This is going to be a 4/1. Keep our first fraction, change the symbol to multiplication, and flip the last one. 4/1 becomes 1/4. And now we're just going to multiply like we're used to. We can cross reduce. 2 goes into 2 once, and 2 goes into 4 twice. Now let's multiply our tops. 1 times 1 is 1, and 3 times 2 is 6. Let me give these a nice circle for you. So we have a couple of word problems. Okay, Samuel uses 2/3 of a roll of ribbon to tie one balloon for the school dance. He has 12 rolls of ribbon. How many ribbons can he tie? This is one when I don't really want to draw a diagram. I'd have to draw 12 things and divide them into 3. I don't really want to do that. So I'm going to just use that we have 12, and we want to divide it by 2/3. We want to know how many 2/3 can we pull out of this 12. So let's keep our first one. So that's going to be like 12/1. So let's keep that, 12/1. Let's change our symbol. It's divide. It's going to become multiply. And we're going to flip our last fraction. 2/3 is going to become 3/2. Now we can cross reduce. 2 and 12 have a common factor of 2. 2 goes into 2 once, and 2 goes into 12 6 times. Now let's multiply the tops. 6 times 3 is 18, and 1 times 1 is 1. So Samuel can tie 18 balloons. Okay, I got cut off, but what I was saying is that you should ask yourself, does this make sense? Samuel can tie 18 balloons. Does that make sense? Yeah, I mean, he had 12 rolls of ribbon, and you can get kind of 2/3 out of it. So one full tie plus a portion of another. So you know it's going to be above 12, but it's not like radically above 12. It's not 24. That would be too many. That would be that he got, 2 ties out of each ribbon. So it does make sense, and you should continue to ask yourselves that with all of your answers. So the last question, I'll do all of this with you, but the key that I want you to take away from this, the key is that the order of a division question matters. So if we have, so here we go. The student knows that 3/4 times 4 is the same as 4 times 3/4. And the student assumes that 4 divided by 3/4 is the same as 3/4 divided by 4. Okay, so not a bad, assumption, let's say, because it's true that 2 times 3 is 6, and 3 times 2 is 6. You can, if we drew it out like this, you could either see this as 2 groups of 3, and if we draw the same thing again, you could see it as 3 groups of 2, but ultimately it's 6. But if we're dividing, if we have, 4 divided by 2, that's 2. But if we have 2 divided by 4, that's a half. So different answers depending on the order. So when we do our keep, change, flip, it needs to be in this order. It can't be flip, change, keep. It needs to be keep, change, flip, and the order of a division question does matter. So I will show you on this number line just for fun. Let's show you 4 divided by, the first one, 4 divided by 3/4. So let's say there's 1, 2, 3, 4. Now we're going to divide it by quarters. So I want to split each of these into 4 sections. And now we're trying to find out how many times can you get 3/4 out of there. So that's 3/4, that's 3/4, that's 3/4, that's 3/4, that's 3/4, and that's 1/3 of 3/4. So that's 1, 2, 3, 4, 5. And that's like 1 out of 3 of the quarters. So that's actually a third. You might be tempted to say it's a quarter. It's not. It's 1 out of the 3/4. It's 1/3. And then the next one, here we have 3/4. So this is 1 over here. We're going to split the whole thing into quarters. So this would be 3/4 right here. And we want to divide it by 4. So I'm going to split each of these into 4 again. 1, 2, 3. Split each of these into 4. And we want to make this in 4 jumps now. So we want to get from here to here in 4 jumps. So it's going to look like this, where first jump is going to be that many, first jump's going to be that many, next jump's going to be that many, and that would be our 4th jump. So we're dividing it into 4. And we want to know how far did we jump each time. That's the divided by part. Okay, so the easiest way to do this is to, I would say, multiply top and bottom by 4. I want to split these into 16ths and make our 3 out of 4 into 12 out of 16. I hope you can see this. I'm at the very bottom of the page, so this is actually now 12 out of 16, our 3 out of 4. And now it's easier to see our jump. So we would make one jump of 3 out of 16, then another jump of 6 out of 16, and another jump of 9 out of 16. And our last one is 12 out of 16. So our answer here, and don't worry, I'm not going to make you do this, but our answer here is 3 out of 16. So very different than our answer of 5 1/3. So the key that I want you to take away is that the order matters, just like if we're using whole numbers. Okay, thank you so much. I'll let you know what textbook questions I want you to do.